In this video, we're going to cover a strategy to determine the number of positive factors, and so let's begin. So 48, and that's going to be 2 times 24, then we can do 2 times 12, then we can do 2 times 6, then we can do 2 times 3. And so what we see is 2 raised to 4. 1, 2, 3, 4 times 3 raised to 1. And that's going to give us 48. And if we list out all the factor combination, we got 1 times 48, we got 2 times 24, we have 3 times 16, 4 times 12, and 6 times 8. So what we count is 10. So the answer to this problem is 10. So now for the technique. So we have 2 raised to 4, 3 raised to 1. And our 2 and our 3 are our prime numbers. This technique is we take the power, 4, we add 1, then we do the other piece. The power is 1, we add 1, and what we're going to get is 5 times 2, which is 10. And so our answer is also 10. Now you can say, why does this work? And for that, I'm going to clear this page a bit. I kept this part, which is all the factors of 48, and I kept this part, our prime factorization. So let's show why it works. So 2 raised to 0 times 3 raised to 0, that's going to give us 1. And 1 is an option. Likewise, 2 raised to 0 times 3 raised to 1 is 3. That's another option. Then we could do 2 raised to 1 times 3 raised to 1, and we're going to get 6. Another option. Then we can do 2 raised to 2 times 3 raised to 0, and we're going to get 4. Another option. Then we could do 2 raised to 2 times 3 raised to 1, and we're going to get 12. Another option. Then we could do 2 raised to 3 times 3 raised to 0, and we're going to get 8. Another option. 2 raised to 3 times 3 raised to 1, and we're going to get 24. Again, another option. And then we have 2 raised to 4 times 3 raised to 0, we get 16. We're almost there. Last one, 2 raised to 4 times 3 raised to 1, and we're going to get 48. So we see, we get everything to be the same. So the big question, why do we add 1? Like, this is an important part, but we say to know the number of positive prime factor, we do 4 plus 1, close it, 1 plus 1, close it. This 1 plus 1. And that's how we get 10. And the whole idea why we have to add 1 is, you could have an example like here. We have no 2's, we have no 3's, and so we get 1, and 1's a factor. Likewise, you have no 2, but you have a 3, so we get 3. That's a possibility. And I just realized I actually missed one. I missed this 2. Well, we can get 2 easy. It's going to be 2 raised to 1 times 3 raised to 0, and we're going to get 2. Which is another example. You have no 3, but you have a 2. And so there's 5 possibilities for this piece, and there's going to be 2 possibilities for this piece. And that's why when you combine them, you'll have 10 possibilities. Okay, so for this problem, we're going to do the same thing. We're going to show all the steps. So 100, we can break it down by 10 times 10, which then could be 2 and 5, which is also broken down 2 and 5. And so we get 2 squared times 5 squared. And so if you want to know the number of possibilities, it's going to be 2 plus 1 times 2 plus 1. 2 plus 1 is 3. 3 times 3 is 9. So 9 possibilities. Of course, we could, list them out ourselves. 1 times 100, 2 times 50, 4 times 25, 5 times 20, and 10 times 10. So 10 times 10, that counts as 1. And then we have 2, 4, 6, 8. So we have 9. Next, I'm going to list it out. And so here, I listed out the other way. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now for this problem. A much bigger problem. Now in this problem, we're not going to do it both ways. We're going to do the shortcut method. So 3,500. We can get that by 35 times 100. 35 we can break down by 5 times 7. 100 can be 10 times 10. Then 2 times 5. 2 times 5. And so we're going to get 2 squared, 1, 2, times 5 raised to 3. 1, 2, 3. Times 7 raised to 1. Now if we multiply it out, 2 plus 1 times 3 plus 1 times 1 plus 1, we're going to get 2 plus 1 is 3, 3 plus 1 is 4, and 1 plus 1 is 2. 3 times 4 is 12, 12 times 2 is 24. And so there are going to be 24 positive factors for 3,500. And that's all we need to do for this method.